simple numericals, and then afterwards some
This call is
difficult
now being recorded.
level numericals we'll go for. So we'll recap fastly. Okay, not audible, na? No problem. Hello, somebody can respond.
Yes,
No
sir.
problem.
Yes, sir.
Yes, sir, audible.
Okay, thank you. So okay, on that day we have started with reversible process and irreversible process. So reversible processes are the processes in which criteria, first of all, reversible process have to undergo is that reversible process, when it occurs in the reverse direction, it should not violate the second law of thermodynamics. So by the first law of thermodynamics was unable to explain us whether the given process is reversible or not. But by the help of second law of thermodynamics, we can clearly say that if we reverse the direction for a process, and if the second law of thermodynamics will not get violated, then that process we call it as a reversible process. So all other things we know about the reversible processes, that the reversible process always there will be always thermodynamic equilibrium in between system and surrounding in all stages. Okay, then reversible process here when it will be coming, that when reverse direction happens, then it will occupy the same path. Reverse path is going to be same as the system undergo in the forward path. Okay, and again I told you that there are very few processes that we can assume it as a reversible processes. Other processes are irreversible, but simple judgment is that here, that whether the process is reversible or not, for that simple judgment is here the process when the direction is reversed, it should not violate the second law of thermodynamics. Violate means it will not follow the second law of thermodynamics. And second thing is that here both system and surrounding should come to the original state. It should not happen that only system is coming to the initial state but surrounding is not coming. It should not happen. So that kind of processes we cannot call it as a reversible process. Both system and surrounding should come to the original initial state. Then that process we can call it as a reversible process. Okay. Sometimes what happens, system may come to the initial condition but surrounding is not coming. So in that case, to come to the initial state, system have to take some amount of work extra from the surrounding or some amount of heat from the surrounding. So in that case, surrounding system is going to give a trace on the surrounding. It should not happen in case of the reversible process. Both should come is when in the forward direction, if the system has given surrounding 10 kilojoule of heat, in reverse direction, system should take 10 kilojoule of heat from the surrounding and it should come to the initial state. It should not happen that in initial in the forward direction, system has given 10 kilojoule of heat to the surrounding, and while reversing, it is taking some extra amount of heat from the surrounding. It should not happen. Within 10 kilojoule only, that system have to come to the original state. Okay, means both should come to the initial state. Then and then only that process is called as what? Reversible process. So that day we have discussed about the processes which do not obey these kind of criteria are simply called as irreversible processes. For example, means all the processes in the universe are irreversible processes. So reversible processes, here we will recap. Reversible processes cannot be realized in practice. All practical processes occurring are irreversible. Then second point, the process can be carried out in the reverse direction following the same path as followed in the forward direction. Then process in the irreversible process when carried out in reverse direction follows the path different from that in forward direction. So path is going to be different in case of the irreversible process, forward path and reverse path. But in reversible process, forward path as well as reverse path is going to be same. The reversible process leaves, this is very important. Reversible process leaves uh, reversible process leaves no trace on the. Okay, I will take a pointer. Okay, so this is going to be reversible process leaves no trace here on occurrence upon the system and surrounding after its reversal, but irreversible processes they are giving trace on this particular surrounding. Okay, then here such processes can occur either direction without violating second law of thermodynamics. Means if we want to achieve the reversible process, then second law of thermodynamics should not get violated at any cost. But in case of the irreversible processes, definitely in if we reverse direction, second law of thermodynamics is get violated. So that process we cannot call it as a reversible processes. Then definitely as reversible processes are the ideal processes, efficiency, any cycle consisting of reversible processes having more efficiency, and irreversible processes here which cycles consisting of irreversible processes, they definitely they are having the less efficiency. So reversible process occurs at infinitesimal rate, that is quasi-static. I told you that day, that is if heat transfer is taking place in between 5 degrees Celsius, okay, or 5 point not 5 point not 1 degree Celsius to 5.0 degree Celsius. So that temperature difference 0.00000001 is very less, equal to 0, tends to 0. That kind of infinitesimal differences are the rate the reversible process will go. Means if we want to transfer the heat from 5 to 10 degrees Celsius, first step we have to go for 5.0 to 5.0001. Next step 5.00001 to 5.00002, and that way the means there is very less heat transfer, nearly static, nearly zero. Then that kind of processes we can call it as a reversible process, and these occurs at very low speed or slow speed. Therefore, they are considered as quasi-static processes. And always there is a thermodynamic equilibrium in between system and surrounding at every stage. But in case of the irreversible processes, here there will be no thermodynamic equilibrium at every stage in between system and surrounding. So examples are there. Very few processes we consider it as a reversible processes. For example, frictionless motion, controlled expansion and compression, elastic deformation, electric current, where no resistance is there. But irreversible processes, all the other processes in the universe are the irreversible processes. For example, viscous fluid flow, inelastic deformation, hysteresis effect, so free expansion. All these considered under the irreversible. So only few processes where the rate of compression expansion is infinitesimal, rate of heat transfer is infinitesimal. That process we call it as a irreversible process, reversible processes. Other than reversible, everything is irreversible. And afterwards, we have taken one cycle which is consisting of all the processes reversible, and that cycle we have discussed as a Carnot cycle. And this cycle is discussed by suggested by Sadiq Carnot, and this cycle consisting of all four processes as a reversible processes. And therefore, in the universe, very few processes are reversible. Hence, it is very difficult to achieve the Carnot cycle. Hence, as reversible processes are very few, not occurring in the universe, therefore, Carnot cycle also remains on paper dream cycle, or we can say it as a remained as a only hypothetical phenomena, and therefore this Carnot cycle remain as a ideal cycle or dream cycle, and it consisting of piston and cylinder arrangement. So that they have considered that piston and because friction we don't want, therefore there is a no friction in between piston and cylinder, frictionless piston we can say. Then all four processes are there. That is four processes as assumptions we have gone for. The piston moving in a cylinder does not develop any friction during motion. The walls of piston and cylinder are considered as perfect insulators of heat. Then the cylinder head. Nice. 1 minute I will enter. इथला हे येत नाही, व्हॉइस येत नाही. ह्याच्यावर बोलतो मी. इथला 1 minute आहे, 1 minute. कितना here here म्हटलं गुगल his here voice is not coming. Dismiss there. Screen share shared. Hello. नाही काहीच येत नाही. व्हॉइस म्हणजे डिसमिस करते इथले. इथले कनेक्शन इथलं ऑन केलं लागते ना. जातानाच हे जायचं काय असं आहे काय. म्हणजे गुगल मोझिला. Sorry, I'm adjusting my here device volume. ATD Lecture. Recording होणार का? Continue. Let's close three. Okay. Hello, am I audible now?
Yes, sir.
Okay. So, reversible processes. So we discussed about piston is moving in cylinder, does not develop friction. Then piston and cylinder are considered as perfect insulators. The cylinder head is so arranged that it can be a perfect heat conductor or perfect heat insulator. Then transfer of heat does not affect the temperature of source and sink, because both temperatures are source and sink temperatures always remain constant. And then we have gone for the four different processes. So isothermal expansion is there one process here. Second is the adiabatic expansion. During isothermal expansion, heat is supplied. Therefore, it is sometimes some books they have given this as a first step as a heat addition at constant temperature. Isothermal heat addition. Some books they have referred this process as a heat addition at constant temperature. This is adiabatic expansion. We are getting the work from the fluid and work we are getting from this. Okay. Then next isothermal compression, or we say it as a here heat rejected at isothermal condition, or isothermal heat rejection. Stage 3. In some books they have written it as a heat rejected isothermal or isothermal heat rejection. And last one is there for we have to supply some heat in compression. That is adiabatic compression. So these four steps are there. So these four steps now we have So this is a isothermal heat addition here. One to two process is there isothermal heat addition where heat is added Q1 amount to temp here. We are now simultaneously will go for two diagrams. PV diagram, this is PV diagram. Okay, this is TS diagram. Okay, left hand side PV diagram, right hand side we are having TS diagram. So PV diagram it is added isothermally one to two process. 2 to 3 is adiabatic expansion. We are getting the work here from this process, W amount of work we are getting. Then 3 to 4, here we are rejecting the heat, that is Q2 amount of the heat we are rejecting. Okay, and here uh, 4 to 1 is the adiabatic compression. Here we have to supply the work for the pump. Uh, then here 1 to T1 is equal to T2 during heat addition and T3 is equal to T4. But for here simplicity, T1 we are considering as a heat addition temperature and T2 is equal to T3 that we are considering as a heat rejection temperature. Now on that day we have now for the this is the BME you have learned that isothermal heat addition is given by our work obtained during that process because cyclic integral of work is equal to cyclic integral of heat. Therefore, Q1 is equal to work happened. It is a Q1 amount of heat supplied is equal to work happened, work done during this 1 to 2 process. Therefore, here it is given by P1 V1 initial condition P1 V1 ln of V2 by V1. Similarly, Q2 heat rejected is happens in 3 to 4 process where the here we can say it as a isothermal compression, like expansion. Therefore, as compression, we have to supply the work. Therefore, negative sign is there. Again, initial condition is P3 V3. Okay, ln of V4 final volume divided by initial volume, and minus P3 V3 ln of V4 by V4. Then P1 V1 because this is isothermal condition. Both we are having isothermal condition. Therefore, P1 V1 is equal to we can say MR T1. Here also P3 V3 is equal to MR T2. Here we are considering that heat is rejected at temperature T2. So T3 is equal to here and heat addition temperature we are considering as a T1 in our diagrams. Heat source temperature T1, sink temperature T2. Then MRT2 ln of V3 by V4 heat rejected afterwards. T1 ln of V2 by V1. Now next step is there that efficiency of any heat engine is given by what formula? Eta is equal to W divided by, we can say it as eta is equal to here W divided by heat supplied Q1. But we know that Q1 is W is equal to Q1 minus Q2 or eta is equal to 1 minus Q2 upon Q1. Now, both Q2 and Q1 equations we are having. Now next step for this proof cycle proof, what we have to do is that this V2 upon V1 is coming as V3 upon V4. That we have to show. Okay, and for that we are going for the next stage because here now we are taking the help of these remaining processes, adiabatic expansion and adiabatic compression, and for that here process here first is the adiabatic expansion 2 to 3 P2 V2 raised to gamma is equal to P3 V3 raised to gamma. Equation 1 we are considering. Then compression, adiabatic compression P4 V4 raised to gamma is equal to P1 V1 raised to gamma. Equation number 2. And then by here PV is equal to nRT. Therefore P by PV by T is equal to nR is equal to C. That also we are considering. Then P2 V2 upon T1 is equal to P3 V3 upon T2. Okay. So this equation ideal gas equation. Then P4 V4 upon T2 is equal to P1 V1 upon T1. That equation also are going to be valid in this case because ideal gas because gas we have considered, fluid we have considered as a radial. Now equation by rearrange mathematical terms, dividing equation 1 by 3, what we will get here after applying all the conditions, T1 into V2 raised to gamma minus 1 is equal to T2 into V3 raised to gamma minus 1 and divide 2 by 4, equation 2 by 4, what we are getting T1 V1 raised to gamma minus 1 is equal to T2 V4 raised to gamma minus 1. Then if we divide this 5 by 6, then we are getting that V2 upon 5 by 6 if you go for, then this if you go for, then here T1 upon T, this T1 will get cancelled, this V here, and then V2 upon, this term will become V2 upon V1 raised to gamma minus 1 is equal to again V3 upon V4 raised to gamma minus 1. And as though we can say base is different, but index is same, we can cancel the index. That is the law of indexing. And therefore, this index is gamma minus 1. This gamma minus 1 will get cancelled. Okay. So gamma minus 1 is going to be cancelled both from numerator and denominator, and we are getting V2 upon V1 is equal to V3 upon V4. So that was our aim. And therefore, as we know that equation eta is equal to 1 minus here eta is equal to 1 minus Q2 upon Q1. So this indicates that here Q2 upon Q1 now, what will be there in the Q2 upon Q1? So previous slide, Q2 upon Q, this V2 upon V1 is same again V3 upon V4. Therefore, ln of V2 by V1 and ln of V3 by V4 will be same. Therefore, MR will be also get cancelled, and this will become T2 upon T1. So this will become finally that efficiency of Carnot cycle engine or reversible cycle engine is given by equation eta is equal to 1 minus T2 upon T1. Now, this is the expression efficiency of Carnot cycle is given by this expression. So this indicates that efficiency of Carnot cycle is function of only two temperatures. I request everybody to open your notebook and remember, write down the efficiency of Carnot cycle. Are you writing? Some notes should be there. Otherwise, I am here sending this PPT, but solving numericals, you should have notes. So I request everybody to write down efficiency of Carnot cycle, or eta Carnot is equal to, at least you write down processes, etc. I will provide notes or PPT. So eta Carnot is equal to, here Carnot cycle efficiency is given by equation 1 minus T2 upon T1. Okay. So write down what is T2 and what is T1. So I request, are you writing? Somebody can reply or the message box. Somebody should give me liveness, otherwise I am teaching. Whether you are sleeping or you are what, I am not getting. Hello. Somebody can reply. Everybody is allowed to reply in such cases when I ask an answer. I ask a question. Hello. Am I audible?
Yes, sir, audible. Audible,
Yes,
sir,
sir.
audible.
Yes, sir.
Am I audible? Yeah. Then okay. Carnot cycle efficiency. At least we'll write some important points. Carnot cycle efficiency. Carnot cycle efficiency is given by Carnot cycle efficiency is given by Carnot cycle efficiency is given by next standard term eta Carnot is equal to eta Carnot is equal to eta Carnot is equal to 1 minus T2 upon T1. Eta Carnot is equal to 1 minus T2 upon T1. Eta Carnot is equal to 1 minus T2 upon T1. Okay. Shall I go for next? Okay. Where now? T1, where T1 is equal to, what is T1? T1 is equal to temperature of heat addition. Temperature of heat addition. T1 is equal to temperature of heat addition. Temperature of heat addition. And T2 is equal to temperature of heat rejection. T2 is equal to temperature of heat rejection. Temperature of heat rejection. Temperature of heat rejection. Okay. Now here write down for getting maximum efficiency. For getting maximum efficiency, for getting maximum efficiency. Next line, right down. First, for getting maximum efficiency. Next line first. Now, for getting maximum efficiency, we'll tell which temperature should be less and which temperature should be more. For getting maximum efficiency, suppose that I want, somebody can reply our message box. Uh, if problem is there writing message box, you can reply. So for getting maximum efficiency of Carnot cycle, which temperature should be less and which temperature should be more, because this quantity we have to make it as a less T2 upon T1, 1 minus T2 upon T1. And to make this less quantity, what is expected? Anybody? For having maximum efficiency of Carnot cycle, if we want to increase the efficiency of Carnot cycle, then here what you can say, T2 should be, anybody? Reply, my friend. Okay, Swat Naste. Q2
T1 में
okay, Q2 means here temperature. Swat correct. You are correct. Q2 and Q1. In terms of Q2 and Q1 you have written. But here Carnot cycle efficiency is function of, we are saying, temperature. So in that case, and should be as maximum as possible. Okay. For maximum efficiency, for getting maximum efficiency, for getting maximum efficiency, heat rejection temperature. Write down. Everything should be written in notes. Heat rejection temperature. Heat rejection temperature in bracket T2. Heat rejection temperature in bracket T2 should be, heat rejection temperature T2 should be as low as possible. Heat rejection temperature T2 should be as low as possible. Next, heat addition temperature T1, heat addition temperature T1 should be as more as possible. Heat addition temperature T1 should be as more as possible. Okay, now here T2 should be lowest and T1 should be more. Then efficiency of Carnot cycle will be maximum. But see that again, one thing, whether efficiency of Carnot cycle is 1, somebody can reply. Efficiency of Carnot cycle is 1 or 100%. Carnot cycle is working on reversible processes. It is working on is ideal cycle. But whether the efficiency of Carnot cycle is 1 or 100%, whether efficiency of Carnot cycle is 1 or 100%, Prathamesh Kodgun is saying that 100%. So others are agree. How, Prathamesh? It is 100%. It is 1 minus. So there should be some heat rejection temperature. There should be some heat addition temperature. So some T2 upon T1, we should have some ratio, some quantity. Therefore, Carnot cycle efficiency is 1 minus some quantity. Means it is 1 minus means it is never, somebody, it is never 100%. So though Carnot cycle is a ideal cycle or dream cycle, its efficiency is never 100%. Forget about other cycles, but ideal cycle efficiency is also not an 100%. So this also we have that day we have completed. Then here we have gone for the diagram. Here 1 to 2 heat addition. Okay. Then heat rejection Q2. Okay. Then we are getting the work here. We are getting work, and here we have to supply the work. Okay. So heat during this process, isothermal process now. Here S1 is equal to isentropic processes. So heat addition is given by equation T1 minus T2 upon Ds or S2 minus S1. And here also heat rejection. Here in that case, what is that? Q1 minus Q2. Okay. So Q2 is equal to here ds T1. What is happening here? I will write here. So heat supplied in that case, it is in that isothermal process. You can say that heat transfer is equal to where change in entropy S2 minus S1, but S3 minus S4 and S2 minus S1 both are same. Therefore, what we can say, it is temperature T1 at which T1 into ds. Okay. And similarly, heat rejected Q2 is equal to S3 minus S4 is equal to delta S. Both are same coming same ds. Therefore, T2 is equal to T2 into ds. Okay. And therefore, Q1 minus Q2 is equal to work obtained, net work obtained is coming as here T1 minus T2 into ds. Here it is there. And efficiency again, it simply we can also whatever derivations we have referred before 5 minutes. This can be also simplified as eta Carnot is equal to here is equal to 1 minus Q2 upon Q1 reversible, or you can say it as a Q1 minus Q2. It can be written as here Q1 minus Q2 divided by Q1. Okay, and in that case, here it is equal to Q1 minus Q2 is equal to what we are getting. It is equal to ds T1 minus. So it is to calculate simply T1 minus T2 into ds Q1 minus T2 upon ds divided by Q1 is nothing but what T1 into ds. Change it. Okay, ds is going to be same. So ds will get cancelled, and efficiency formula will become eta is equal to T1 minus T2 divided by T1, or simply you can say 1 minus T2 upon T1. So here I request you that to note down the formula. So for Carnot cycle efficiency, we can say it as a eta. Yeah, Carnot cycle is a maximum cycle, it is ideal cycle. Therefore, efficiency of Carnot cycle is always maximum. Okay. Though it is less than 1, but it is maximum than the other irreversible cycles. Therefore, eta reversible is equal to eta maximum. It is given by equation 1 minus Q2 upon Q1 reversible, or is equal to 1 minus T2 upon T1. Or for Carnot cycle, I request everybody to write down for Carnot cycle, write down for Carnot cycle, 1 minus Q2 upon Q1. Here everybody for solving numericals, this is going to be important data. 1 minus Q2 upon Q1 is equal to 1 minus T2 upon T1. Only this is valid for reversible cycle or Carnot cycle. 1 minus T2 upon T1. Okay. 1 minus Q2 upon Q1 is equal to 1 minus T2 upon T1. 1 minus 1 minus will get cancelled. Therefore, for Carnot cycle, we see that Q2 upon Q1 is also equal to, okay, understand my handwriting, is equal to T2 upon T1. So note down this. Q2 upon Q1 is also equal to T2 upon T1. So 1 minus Q2 upon Q1 is also equal to 1 minus T2 upon T1. Therefore, Q2 upon Q1 is equal to T2 upon T1. This is also going to be valid for which cycle? Carnot cycle. Or again, this is also going to be same. So T1 or T1 minus T2 upon T1 minus T2 upon T1 is equal to Q1 minus Q2 upon Q1. It is valid only for reversible cycles or Carnot cycle. Now, this is I think we have learned. I will not here. This Carnot heat pump. Okay, exactly opposite to the here Carnot heat engine. It is reversible heat pump. Okay, so whatever the process are there, here it is taken from low temperature body and it is supplied to the high temperature body, and for that we are supplying the work. So this is working on reverse Carnot cycle. Therefore, it is called as Carnot heat pump. And again, for Carnot heat pump also, here we can say same equation. That is what COP of Carnot cycle. Anything is given by equation. So COP of Carnot cycle is given by equation what? Heat pump. So heat pump, we know that it is equal to COP of heat pump. What is formula for COP of heat pump? Write down this also. For Carnot heat pump, write down in your notebook. For Carnot heat pump, COP of heat pump is equal to, write down, for Carnot heat pump, COP of heat pump is equal to, what is formula for us? For our formula is what? Q1 heat supplied. We are interested in heat supplied divided by work, net work W. Okay, but this W is equal to what? We know that is equal to Q1 divided by Q1 minus Q2. So this formula everybody should remember. Okay, write down. What is that? Carnot heat pump is equal to COP of heat pump. Which pump? Carnot heat pump. Heading U, Carnot heat pump. COP of Carnot heat pump is equal to Q1 divided by W is equal to Q1 divided by Q1 minus Q2. And for this is also valid reason, validity is there. Only write down for Carnot heat pump. For Carnot heat pump, Q1 write down Q1 divided by Q1 minus Q2. Again, temperature ratios are also same. What is also equal to Q1 divided by Q1 minus Q2 is also equal to T1 divided by T1 minus T2. This is also valid for Carnot heat pump. So when numerical will be there for the Carnot heat pump, what we have to write? For Carnot, this is valid for Carnot heat pump only. What is that formula? Write down Q1 minus Q2 is equal to T1 divided by T1 minus T2. Q1 divided by Q1 minus Q2 is equal to T1 divided by T1 minus T2. Okay, this is for Carnot heat pump. Now, next, are you writing? Tell somebody, order I am telling, are you writing?
Yes, sir.
Okay, without this, we cannot solve the numericals. Remember that. All the formulas are there. COP of heat pump, COP of Carnot heat pump, what is formula? Then, next, we will go for, next is there, Carnot refrigerator. Write down in your notebook. Carnot refrigerator. Now, same Carnot heat pump and Carnot refrigerator, both are same. So, means only intention is going to be different. So, Carnot, the refrigerator which is working on reverse Carnot cycle is called as Carnot refrigerator. Write down there. Carnot refrigerator. The refrigerator working on. Everybody, I request to take the notes. Okay. Carnot refrigerator. Write down. The refrigerator working on. The refrigerator working on reversed Carnot cycle. The refrigerator working on reversed Carnot cycle is called as Carnot refrigerator. Means all the processes are reversible. Remember that. Because Carnot cycle consisting of all the processes are reversible processes and isothermal processes. So Carnot refrigerator, okay, so it is equal to here the refrigerator which is working on reversed Carnot cycle is called as Carnot refrigerator. Now, next line, write down. COP of refrigerator. What is formula for COP of refrigerator? Anybody? COP of refrigerator is equal to what is? Now, what is intention for refrigerator? Anybody? Intention for refrigerator? Whether heat absorbed or heat supplied? Somebody can reply so that I can get that. Are you getting? You are getting. Okay. For refrigerator, what is input? What is expected? How much amount of heat? How much amount of heat absorbed or supplied? Was Namaste, Pramesh, Kodgun, Pramod Aulikar. So how much? What is your intention? Swas.
Absorbed.
Heat absorbed. Then speak now. What is heat absorbed here in this case? In that refrigerator?
Q2.
Q2. Here it is supplied is Q1. So if we go for cycle of refrigerator, okay. So heat is absorbed means Q2 amount of heat is we are absorbing. So here you can say this is going to be, so intention is Q2 okay, divided by work is W. Okay, shall I? Then here in that case, but we know that W is equal to Q1 minus Q2. Therefore, Q2 divided by Q1 minus Q2. So remember that. So write down this formula. Already on that day we have explained that formula. So COP of any refrigerator, whether it is Carnot or simple refrigerator, COP is given by the formula. Write down. COP of refrigerator is equal to Q2 divided by W, Q2 divided by W, or as W is equal to Q1 minus Q2. So this is equal to Q2 divided by Q1 minus Q2. Then, but for Carnot refrigerator, these heat interactions are equal to temperature interaction. Therefore, write down, for Carnot refrigerator, for Carnot refrigerator, for COP, for Carnot refrigerator, next line, COP of Carnot RE Carnot refrigerator. We have considered this as a E. COP of Carnot refrigerator is equal to, what is formula? Q2 divided by Q1 minus Q2. For Carnot refrigerator, Q2 divided by Q1 minus Q2 is equal to, again it is equal to temperature ratio. Therefore, T2 is equal to what? T2 divided by T2 divided by T2 divided by what? T1 minus T2. Write down. So write down the formula. Carnot refrigerator COP is also given by heat interactions. Q2 divided by Q1 minus Q2 is also equal to Q2 divided by Q1 minus Q2 is also equal to T2 divided by T1 minus T2. Q2 divided by Q1 minus Q2 is also equal to T2 divided by T1 minus T2. So, Carnot, it is cycle engine or do Carnot heat pump or Carnot refrigerator, COP or efficiency are also functions of temperatures. Two temperatures, heat addition temperature and heat rejection temperature. So this is going to be general. This is in terms of heat. These formulas are for general. It may be applicable for reversible cycles or irreversible cycles. Okay. So this formula is everybody have to remember. Without formula, we cannot solve the numericals. Then Carnot cycle cannot be performed in practice because of the following reasons. So that they have partially covered. What is that? Here, it is impossible to perform a frictionless process. Always there is a friction present in between two things. Okay. Then impossible to transfer heat without temperature difference. Means isothermal temperature heat addition and isothermal temperature heat rejection is not possible. So it is impossible to heat rejection as well as heat addition isothermally. It is impossible. Therefore, it is not possible. Then isothermal process can be achieved only if piston moves very slowly, means quasi-statically, to allow the heat transfer. Because heat transfer we want at very infinitesimal temperature difference. So due to these reasons, isothermal heat addition is not possible. Isothermal heat rejection is not possible. Then impossible to have the frictionless process. Okay. Then here piston moves fast, so quasi-static process is not going to be possible. Therefore, this cycle remained on paper. It is not practically possible. Carnot cycle is only theoretical cycle, ideal cycle, only hypothetical cycle, not giving any idea about the actual case. Then we have covered the Carnot cycle that day. I have taken revision because On that day, I think due to sound problem was there, some visibility problem was there. Therefore, I am taking again this very slowly. And on that day, I have not asked her to write down the formulae. But today I realized that without formulae, you cannot solve the numericals. Is it okay? Somebody can reply. Otherwise, I am feeling that I am only speaking. You are whether you are watching or not.
Yes,
That
sir.
way, interaction should be there. Okay. Now on that day, I think we have also covered the equivalence of Clausius statement to the Kelvin-Planck statement. Or also we say in general, that is, it is equivalence of second law of thermodynamics, because both are Clausius statement and Kelvin-Planck statement. Both are your second law of thermodynamics statement. Therefore, it is simply it is called as equivalence of second law of thermodynamics. Now, what is equivalence? What is equivalence? So equivalence is nothing but here the these two statements. So we if we see Kelvin Planck statement, we are applying it for heat engine. So this is a Kelvin Planck statement KP. I'll write in short KP heat here. Kelvin Planck statement we generally apply for heat engine, and Clausius statement generally we apply for heat pump. So if we study the statements of both these second law of thermodynamics, Kelvin, Planck, and Clausius, then both are different. Wording is also different. Physically, they also look different. Then Kelvin, Planck, one statement is applicable for heat engine, and one is applicable for heat pump. Okay. Then, if we want to apply these two statements for a common device, then they show strong relationship with each other, or they show some strongly relation with each other when they are used in common device. When they are using separately, there is no relation. But when these two statements we have to use in common device, then they show strong relationship with each other, though physically they are different. Okay, and that is called as equivalence of second law of thermodynamics. So here the Kelvin, Planck, and Clausius statements are second law are equivalent. That is, if we violate. Now, how to explain it? Now here first case we'll take. That is, uh, if we violate Kelvin, Planck statement, then Clausius statement of the second law also get violated. Means if one statement is true and another is violated or not obeying, violating means not obeying, then the statement which is true also not violate, also get violated. This is called as equivalence of second law of thermodynamics. What is that? Now here Clausius statement is violated. Here is what first time Clausius statement is not true, violated, and Kelvin Planck statement is true. How is true? Because heat engine is there. It is taking Q1 amount of heat. Okay, it is taking Q1 amount of heat, performing network Q1 minus Q2, and rejecting some heat to the low temperature reservoir T2. So if we don't consider left hand side, Clausius side, only if you consider this as this only this part, then what will happen? This is a heat engine. Q1 amount of heat is taken, W amount of it is work is performed, Q2 is rejected. Okay. Then means this is a very true with Kelvin Planck statement. So therefore Kelvin Planck statement is not violated. Now see now left hand side. What is left hand side? No work is written. There is written what? No work. Means heat pump is extracting Q2 amount of heat from low temperature source, low temperature sink, and supplying to high temperature body or reservoir having means Q1 amount of heat. But this heat pump is not taking any work from surrounding. Then whether it is possible to transfer heat from low temperature reservoir to high temperature reservoir? Anybody can reply. Without work, whether it is possible?
No.
Without work, whether it is possible? Swas or somebody can reply. It is not possible. Others also, though I am having names on screen, I am taking their names. Others think, should not have to consider that sir is taking only few names. Okay, I am not knowing all names. Okay, anybody can reply.
Not
So
possible, sir.
without work, whether heat transfer is possible
Not
from.
possible.
No, sir.
Okay. Then means here Clausius statement is not obeying the law. Clausius statement is not obeying means Clausius statement is violated and Kelvin Planck is true. But as Clausius is violated, Kelvin Planck will also next year. Here Kelvin Planck statement will also here get violated now. How it violated now? Now, this heat pump and heat engine we have to consider is a common device. It's a common device. Now here, common device heat supplied is going to be same. So Q1 amount of heat is there and heat rejected is Q2. And here, what this device is doing now? Q2 here, this device is not taking. So whatever the Q2 here Q1 is greater than Q2. Okay. So this device, what it will do is Q1 all here because to have the Q2 is equal to here to whatever the heat is there developed by the work developed by engine is supplied to the heat engine. This heat is going to this work we are supplying to the heat engine. So W is equal to Q1 minus Q2. Okay. This is going to be Q1 minus Q2. Okay. This is going to be supplied to the heat pump. Okay. This is Q1. Now if we go for the here our case, so incoming is Q1, work developed is Q1 minus Q2. Okay, and this to have the and this is going to be rejected. So to have this Q1 minus Q2, this Q2 should be equal to 0 because all amount of network is supplied to the heat pump. Therefore, here this Q2 will become 0. There is no Q2. And if this Q2 is remaining 0, coming as 0, then we say that here no heat is rejected by the this combined device. And therefore, we say that Kelvin Planck statement is also get violated. Means initially Kelvin Planck statement was correct. But as Clausius statement was showing wrongness, Kelvin Planck statement in common device also showed the wrongness. And this is called as what? Equivalence of second law of thermodynamics. Similarly, violation of Kelvin Planck statement leads violation of Clausius statement also. Here we see here in the device now, heat engine, heat pump is there. It is extracting Q2 amount of heat, taking work W and rejecting to the high temperature reservoir Q1. T1 is Q1. Okay. So heat pump is taking W, therefore it is what? It is not violating, it is true. Now here it is what? Clausius statement is CL means Clausius statement is true. Okay. Okay. But Kelvin Planck statement, what is about Kelvin Planck statement now? So Kelvin Planck statement taking Q1 amount of heat, okay, developing W is equal to Q1, supplying to this heat engine, okay, and Q2 is equal to become 0. So Kelvin Planck statement will become what? Here false or violation. Okay. Now this is going to be individual case. Kelvin Clausius is true, Kelvin Planck is violating. But in common device now, common device what is acting? Here this heat pump is taking heat, taking work from heat engine W, not taking from external. So external work is not there. Okay, only internal work W is equal to Q1. It is taking and it is supplying Q2 amount of heat to from low temperature reservoir to high temperature reservoir. Okay, to high temperature reservoir, and therefore without taking external work. In that case, what happens? Though initially Kelvin Planck statement was true, in common device, Kelvin Planck statement is also showed a falseness because his friend Kelvin Planck is also showing falseness. So Clausius showed the falseness as Kelvin Planck is showing falseness. Means something is there in between them. That is some relationship in between them, and that is called as equivalence of second law of thermodynamics. Or in short, what we say, if violation of Kelvin Planck statement leads violation of Clausius, or vice versa. Vice versa means what? Violation of Clausius statement leads violation of Kelvin Planck statement. Means in common device, these one statement is violating, another statement how to violate. That is called as Kelvin. That is called as equivalence of second law of thermodynamics. Now on that we have see the example. That is one fridge is there, refrigerator is there in the room, and if the doors of refrigerators are open, and if this electricity were giving to the refrigerator, whether room will heat or cool. Already maximum student given answer. It is heating, and it was correct. Okay. So now on that day we have covered also fastly the Carnot theorem. What is Carnot theorem? Here, if a heat engine, one is reversibility engine and another is what? Irreversible heat engine. So this is HE is or irreversible heat engine. Okay, and another is or reversible heat engine. Okay, if these two heat engine, one is working on irreversible processes and one is working on reversible processes, which engine efficiency will be more if their temperature limits are same? Anybody? Which engine efficiency is more if temperature limits are same?
Reversible heat engine.
Reversibility engine. Okay. So what is that? Efficiency of, write down. I think we have already written, but write down. Efficiency of reversible heat engine. Write down. Give name Carnot theorem 1 or Carnot theorem. Give name Carnot theorem. Write down Carnot theorem. In simple language, we will write efficiency of reversible heat engine. Efficiency of reversible heat engine. Efficiency of reversible heat engine is always efficiency of reversible heat engine is always more than efficiency of irreversible heat engine. 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 If both heat engines, both means reversible as well as irreversible, both heat engines are working between same temperature limits, at that time both heat engines is here, reversibility engine is having more efficiency. So write down for it again, I will explain. Efficiency of reversible heat engine is always more than efficiency of irreversible heat engine if these engines are working between same temperature limits. These are working between same temperature limits. Okay. This is called as Carnot theorem. Means what? Here, if you diagram, I will supply this PPT. So, what is that? Efficiency of which engine is now reversible? HEA. What do we get? HEA heat engine. HEB is reversible. So, HEB is reversible. Therefore, what we can say here? This proof is there. Okay. So, eta B is always greater than eta B, eta A, or WB is greater than WA. This is for the proof they have given. Eta B is always, write down eta B is greater than eta A and WB is greater than WA. Means work obtained from reversibility engine is always more than work obtained from irreversibility engine. Write down where the eta B is reversibility engine, A is irreversibility engine. Now, another thing is this proof is not there for our syllabus. Then another theorem is there that if both heat engines are reversible, and their temperatures of source and sink is same. The temperature of source and sink is same. Then what's about efficiency? So here one statement is given. Anybody write down? Here this is going to be statement. Write down. Here. Corollary of Carnot theorem. Corollary. Vyatyas, we can say in Marathi. Vyatyas. Pramay is there. Theorem means pramay. Okay. Corollary of Carnot theorem. Corollary of Carnot theorem. Corollary of Carnot theorem. Or is also called as Carnot theorem 1. Corollary of Carnot theorem 1. Carnot theorem is called as Carnot theorem 1. Then, now what is that? Efficiency of, write down, efficiency of all reversible heat engines. Efficiency of all reversible heat engines operating between same temperature limit is same. Efficiency of all reversible heat engine operating between same temperature limit is same or same. Efficiency of all reversible heat engine operating between same temperature limit is same or same. So all reversible heat engines working between same temperature limits have same efficiency or have equal efficiency. Likewise, we can generate similar statements, no problem. But understanding is that reversible heat engine, both all those are having same temperature limits. Both those are having source temperature same, sink temperature same, have same efficiency or can generate same work if the temperature limit is going to be same. And this is going to be there. This everybody out, right? Now, here we have studied now reversible processes and irreversible processes. Okay, and now first law of thermodynamics was not telling whether the given process is irreversible or reversible. Okay, now for that one Clausius, whatever our statement, second law of thermodynamics, Clausius statement is there. He came with one another principle, another theorem, and that is called as Clausius inequality. It is called as what? Clausius inequality. Okay, write down. Now write down Clausius inequality. Everybody, I request to write down. Otherwise, if small these highlighting points are not there with you, then it is very difficult to solve the numericals. Today I am taking very slow lecture because that 2 lectures, I think internet problem, the sound problem was there, and internet that visibility problem was there. Today I think we are getting good contact, good internet, sound problem is also not there, and we are having good visibility. Therefore, I am taking this lecture slowly. Disturbances are very few today. I'm thankful to everybody. Thankful to your internet of our college. Okay, internet provider of our college. Okay, write down. Clausius inequality. Write down. Whatever I am writing, write down. The cyclic. Write down. The cyclic integral. The cyclic integral of this dq by t. Write down. Cyclic integral of dq by t. This here, whatever I written. Del q by t or cyclic integral of dq by t is in word, write down, is less than write down in word the cyclic integral of, I am again repeating, okay, give heading Clausius inequality. Write down the cyclic integral of del q by t. Here I am writing, okay, is less than, like in word what I am writing on screen, less than or equal to 0, less than or equal to 0. What is written? Write down the cyclic integral of del q by t or dq by t, you can say, is less than or equal to 0. Write down less than or equal to 0. That is called as crosses inequality. So proof is not there. This crosses inequality earlier in our syllabus was there, but now to solve the numericals or to understand the entropy principle, it is required for us. Okay. Then mathematics, write down. Mathematically, are you writing? Everybody writing now? Suhas?
Yes, sir.
Okay. The cyclic
Yes, sir.
integral of del cube by t is less than or equal to 0. Mathematically, write down. Mathematically, this is everybody know. This is symbol of what? Cyclic integral. This is cyclic integral symbol. Okay. This symbol is what? Cyclic integral. Okay. So cyclic integral of what? D del cube by t is less than or equal to 0. This is called as what? Clausius inequality. What is that? Cyclic integral of dq by t is less than or equal to 0. So here I will write also cyclic integral of dq by t is less than or equal to 0. Similar to this. Now write down below that significance of this Clausius inequality, because to solve the numericals we have to use the significance. Significance of Clausius inequality. Write down that in note. Significance of Clausius inequality. Significance of Clausius inequality. Write down heading significance of Clausius inequality. Significance of Clausius inequality. Write down first case 1. Okay, case 1 or first, write down first significance of Clausius inequality. In that first, write down first point. If 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 cyclic mathematically, if cyclic here, if cyclic integral, right, in mathematical order, whatever I have underlined. Okay, now cyclic integral of dq by t is equal to 0. If this cyclic integral of dq by t is equal to 0, then have written cyclic integral of dq by t is equal to 0, then next time then cycle is reversible. The cycle is reversible. Written MCQ they are going to ask, what is this? If cyclic integral of dq by t is equal to 0, then that process or that cycle is reversible. Everybody getting now how to identify cycle is reversible or irreversible, or that process is reversible or irreversible? During that process, we have to calculate this cyclic integral of dq by t. dq by t value we have to calculate, and if it is equal to 0, then that is called as what? Reversible cycle. Everybody getting now? Somebody can reply me. When cycle will be called as reversible cycle? Somebody, anybody can take unmute and they can tell. When cycle is reversible according to Clausius equality, or this is called as equality in that case because it is equal sign is there. When in general inequality less than or equal to, but here equality means when cyclic integral of dq by t is equal to 0, then cycle is reversible. How to calculate this dq by t, cyclic integral dq by t, I will tell, but now everybody have to remember. Okay, who will tell cycle when cycle is reversible? Somebody can unmute and tell when cycle or process is reversible.
When cyclic integral of dq by t is equal to 0, then the cycle is reversible.
Correct. Your name was na? Okay. So cyclic integral of dq by t is equal to 0, then cycle is reversible. Now second case, write down. Second case, write down. Writing second case, write down. If cyclic integral of, write down, if cyclic integral of dq by t is less than 0, if cyclic integral of dq by t is less than 0, if cyclic integral of dq by t is less than 0, I don't know, then dash then who will tell, cycle is, then cycle is, second condition we're writing, if
Reversible.
cyclic integral of dq by t is less than 0, then cycle is,
Irreversible.
then cycle is, anybody, cycle is
Irreversible.
or cycle is or
Irreversible.
processing, simple, already I underlined, irreversible cycle. Okay, if cyclic integral of dq by t is less than 0, then cyclic integral is, then that cycle is irreversible cycle. Cycle is what? Irreversible cycle. Written second case. Now third case also write down. It is not written here on PPT. In PPT, I will write case 3. So case 3 or third case. With me, you write down case 3. We are writing sixth significance of process inequality. Case 3 or third point. Write down if cyclic integral of dq by t, cyclic integral of dq by t is greater than 0. We're not taken this condition. If cyclic integral of dq by t is greater than 0, then cycle is impossible. It is never possible. Cycle is a process or cycle oblique process is impossible. Okay. So I think who will tell now all these three cases and process inequality, so that I will take some rest. Suhas, LCR, CR na? Suhas must stay.
Yes, sir. Yes, sir.
Read otherwise. Read or without reading also, if you are reading, then good. It
Hello.
will be appreciable. Suhas,
Yes, sir.
read process inequality and one by one significance.
Clauses inequality. The cyclic integral of dq by t is less than or equal to 0. Mathematically, cyclic dq by t is less than or equal to 0. Significance of clauses inequality. Case first, if cyclic integral of dq by t is equal to 0, then cycle is reversible. Case 2, if cyclic integral of dq by t is less than 0, then cycle is irreversible. Case 3, if cyclic integral of dq by t is greater than 0, then cycle or process is impossible.
Good, very nice. Suhas, thank you. Okay, so that way I think everybody should concentrate. Okay, so cyclic this process inequality gives us, or second process inequality is nothing but what proved by Clausius, who has interpreted second law of thermodynamics. Means by the second law of thermodynamics, we can judge whether the process is reversible or irreversible. Wow, how we have to calculate the cyclic integral of dq by t in that given cycle or process, and if the cyclic integral of dq by t is coming as 0, then cycle is reversible. If it is coming less than 0, cycle is irreversible. And if it is coming greater than 0, cycle is impossible. Okay. Now, here how to calculate the cyclic integral? Very simple. Cyclic integral of dq by t. Okay. Now, we are having one heat engine. This is, we are considering this as a heat engine. Okay. This heat engine is having source at temperature Q1, and this heat engine is taking Q1 amount of heat. This heat engine is taking Q1 amount of heat, okay, and rejecting Q2 amount of heat to the sink at temperature T2, and developing work is equal to WE or heat engine work is W is equal to Q1 minus Q2. Then This is the entire cycle. This is entire consider as what this is entire cycle is there. Okay. And therefore, how to calculate this cyclic integral of dq by t? Okay. So dq by t is equal to cyclic means what? Cycle integration means it is nothing but what? Cyclic means the integration taken over the cycle. Cycle or sorry. So this is the integration taken over a cycle. Means it is summation. Integration is nothing but what? Summation. Then what is summation? Heat interaction. dq means what? Heat interaction divided by temperature at which it is interacting. Now here Q1. What is heat interaction? Q1 is supplied. Okay, therefore it is positive. Sign convention also we have taken into consideration. Q1 is positive. Divided by temperature at which it is supplied. What is that? It is summation we have to go for. It is equal to T1. Q1 divided by T1. Q1 divided by T1. Here, plus. You can summation means plus. In bracket now. Q2. But Q2 is what? Anybody? Q2 is what? Anybody? Swas or anybody? Prathamesh?
Heat rejected.
Heat rejected. But and heat rejected we are considering as a positive or negative? Heat rejected we are considering as a positive or negative? Sign conventions of heat.
Negative.
Negative. Therefore, Q1 divided by T1 plus minus because heat is rejected. Therefore, Q2 minus T2. So this is nothing but what? For this heat engine, this is the cyclic integral of dq by dt. Q1 divided by T1 plus minus Q2 divided by T2. Or simply we can say it as a Q1 divided by T1 minus Q2 divided by Q2 because this minus sign will take it here. And if it is coming less than 0, then cycle is irreversible. If it is coming 0, then who will tell? Is Q1 upon Q2. Q1 upon T1. Okay, minus Q2 upon T2. It is coming 0, then cycle is anybody? Anybody?
Reversible.
Reverse.
Reversible.
Reversible cycle. Good. Then draw the diagram and write down calculation of dq by t. So for our understanding in notebook, write down calculation of cyclic integral of dq by t at the heading, subheading. Calculation of cyclic integral of dq by t. Calculation of cyclic integral of dq by t. Calculation of cyclic integral of dq by t. Write down now. This diagram we draw. One source at temperature T1. Okay. Source at temperature T1. Supplying Q1 amount of heat to the heat engine. Or instead of writing here heat engine, here you can write only HE. Then don't write heat engine here. And developing W is equal to Q1 minus Q2, low temperature. And in this case, okay. Then here write down Q1 means draw the diagram and then write down cyclic integral dq by t is equal to what? Q1 divided by T1 minus Q2 divided by T2. If it is less than 0, irreversible, equal to 0, reversible. Draw diagram and then write down. What is meant by cyclic integral of dq by t? Here in this case, you will here write down. Cyclic integral of dq by t is equal to Q1 divided by T1 plus minus. Why minus? Because here write down here reason. Because minus sign is negative sign indicate that it is rejected. So Q1 upon T1 plus minus Q2 upon T2 and is equal to write down this. Here Q1 upon T1 minus Q2 upon T2. So this way everybody have to calculate the cyclic integral of dq by t. Here we are having only two reservoirs. One is high temperature at T1 and another is low temperature T2. If third reservoir is also there, okay, and let's consider that third reservoir is also there. That here also one temperature reservoir is there T3. Let us consider. Don't write now. Okay, and if this third reservoir is also supplying Q3 amount of heat. Everybody getting diagram? So this now I am considering third reservoir. Okay, so third reservoir is having temperature T3. Okay, and is also supplying, let us consider it is also supplying here. This heat engine is taking heat from two reservoirs, one is from T1 and one is from T3 temperature. Then, and it is doing work same Q1 minus Q2. Okay, and rejecting to only low temperature reservoir T2. Then what will be our dq by t? Cyclic until dq by t in that case. Anybody can tell? Third engine, if you third reservoir if you go for. Anybody can tell? Anybody? Singan, Kandule, Swahas. Okay. So what will be cycling interval dq by t in that case? Anybody? Q1 divided by
Q1
tell. I will write
Q1
Q1
T1
divided by
divided by T1 plus
okay.
T3 divided by
Okay.
T Q3 divided by
Very nice.
T3
Divided by
minus
T3
Q2 divided by T2 is equal to 0.
minus or plus? Minus na?
Minus T
Minus
minus
because
T2
heat is
minus
rejected. Here heat is rejected,
mm,
it should be minus. So in that case, here the cycling of dq is equal to Q1 divided by T1 plus Q2 divided by T3 because it is supplied by the reservoir and minus Q2 divided by T2. And if this calculation will come 0, then cycle is
reversible.
if reversible. And if it is not coming 0, then cycle is irreversible.
Irreversible.
Okay. So this basic is required for us to solve the numericals. Because on that day I have taken numericals. Some formulas were there, but at that time we have one for. Now we'll go for numericals. No, I think many students are coming for attendance. Such things should not happen. Rohit Dundle, only writing roll number. When I will ask you, put your roll numbers, give attendance. At that time, you can write your roll numbers. Now, everybody will get that Rohit is came for giving attendance. Only attendance. Why you are worrying? And now today, one circular came from Solapur University. They have told us specifically that start online lectures, and this attendance will be considered for your this semester. So don't remain absent. Today only I am writing one notice to all of you. Already we have started this classes. What are some numericals that day we have taken because, but today we'll repeat this because okay. So we'll take pause for 1 minute. So 2:48. At least we are having again at least 20 minutes. We'll take consider. So 3-4 numericals we can solve. So I request everybody to take with you some pen, notebook already it is there. Calculator also you take with you. Okay. Now here one numerical. First numerical. Determine. So first don't go for direct solution here. Don't see it solution. Determine the heat to be supplied to a Carnot engine. Now here it is not Carnot engine because many numericals they are consisting of Carnot cycle involved in it. Carnot engine operating between 400 degrees Celsius and 1500 degrees Celsius and producing 2 kilojoule of work. 2 kilojoule of work. Determine heat to be supplied. Now, what is given? Heat engine operating means what? W. This is given what? So draw the schematic for this. So temperature, heat engine is having source temperature 400 degrees Celsius. Okay. And it is giving Q1 amount of heat to the source heat engine. Developing W is equal to 200 kilojoule. and rejecting heat is equal to Q2. And temperature of heat engine working between is what? 15 degrees Celsius. Then they asked what is Q1. Now, as this heat engine is what? Carnot heat engine. As this heat engine is what? Carnot heat engine. What we can say? Q1 divided by Q2 is equal to T1 divided by T2. Q1 divided by Q2 is equal to T1 divided by T2. Okay. Now, here W is equal to Q1 minus Q2. Or first calculate. Here we want to calculate here this Q1. Okay. And W is equal to Q1 minus Q2. Therefore, Q1 minus Q2 is coming as here. What is the ratio? Here we know that Q1 T1 means here. Remember that temperature should be always in Kelvin. So plus 273. So 400 plus 273 is what? 673. And Q2, how much amount of heat is here? Temperature T2 is 15 degree. 15 degree means Celsius means 278 Kelvin. So both should be in Kelvin. Okay. Then Q1 divided by Q2 is coming as, and Q1 minus Q2 is equal to W is equal to 200. So these two equations are there with us. So one is Q1 divided by Q2 and another is Q1 minus Q2. Then if we solve this, here we get Q1 is equal to 349.6 kilojoule and Q2 is already 149.6 kilojoule. Okay. Now I'll change the values and I will put a numerical to you. Okay. Same numerical. Determine heat to be supplied to a Carnot heat engine operating between 350 degrees Celsius. Let's take the heat. 350 degrees Celsius and 25 degrees Celsius. Temperature now I have changed it to 400. I have changed to 350, and here this rejected temperature. Here I have taken as a 25 degrees Celsius. And let us consider work developed is 200, or we will consider here 150 kilojoule. So this value 350 is the first high temperature source temperature, 25 is the sink temperature, and 150 kilojoule is the work octane. Now I am asking you calculate the heat supplied in this case. Anybody? So solve the equation. Values are changed now. Temperature is given as source temperature 350, source sink temperature 25, and work obtained is 150. Solve. Today I think screen is visible, voice is audible, no problem. Are you solving or not? Or only we are wasting our time? Ajit Gaikwad, today you are not interacted. Huh? Solve it, Ajit. Every time you are active. Ajit, are you solving? Ajit Gaikwad, Patil, Neha Patil.
Yes, sir.
Solving na? Solve it.
Yes, sir.
Okay. So solve it. Neha Patil, are you solving? Girls representative. Are you in lecture? Patil Neha. This is
Yes, sir.
going at. Are you solving?
Yes, sir.
Okay. I'll give 5 minutes. Okay. Solve it. Why this much time is required? I don't know. Conversion is there. Shubham, okay, okay, good, good. 287.6. Shubham Gandule is showing answer. Let and Pramod Aulek, uh, Aulekar is also showing same answer. No problem. I think both are. Then Ajit is also there. Is also 287. So I think 287.6 is the correct answer. Okay, Prashant Mali. So no problem. 287.61. 287 is the correct answer. Good, 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 good. So Bhaijan is also there today. Okay.
Yes, sir, present.
Okay, okay. So last few lectures we have faced the problems, I think, of internet. Huh?
Yes, sir.
Today going well, na?
Yes, sir. Well, everything fine.
Okay. Let's hope that everything next future also everything will be like this. Huh?
Yes.
Okay. Ganeswar Misal, okay. 287. Okay, no problem. And this kind of simple numerical they may ask for 4 to 5 mark. Only we should remember the formula of Carnot cycle efficiency. What is Carnot refrigerator? Carnot here heat pump, Carnot heat engine. Okay. And next problem. Deepak Vibhuti. All I congratulate all. Those are getting answer. Gorak, okay, Shaneshwar Swas, okay, 287.6 kilojoule. Okay. Then here a domestic refrigerator maintains temperature of -8 degrees Celsius when the atmospheric air temperature is 27 degrees Celsius. Assuming the leakage of 7.5 kilojoule per minute from outside refrigerator, determine the power required to run this refrigerator. Consider refrigerator as Carnot refrigerator. Now, a domestic refrigerator maintains temperature of -8 degrees Celsius. Means what is given? So it is source or sink temperature. Anybody? So minus less temperature means what? Sink temperature. So it is what? Sink temperature is given as what? -8 degrees Celsius. Okay. And source temperature is what? T1 is equal to 27 degrees. So this is going to be T1. Okay. This is going to be T2. Okay. So in Kelvin, we have to convert. So T1 is equal to, I think, 300. If 273 plus 27, 300, and minus 8 plus 273 is what? 268 Kelvin. Sorry, 265. 265. 265 Kelvin. Okay. Now, assuming leakage kilojoule from outside to a refrigerator means what? Here, whatever the, if door is open to that refrigerator, 7.5 kilojoule per minute of heat is entering into the refrigerator. That is called as leakage for the refrigerator. Okay. And that to maintain the same temperature, -8 degrees Celsius, what is our aim is this 7.5 kilojoule per minute of heat, whatever the leaking inside the refrigerator, we have to remove. Then and then only this -8 degrees Celsius will be remain constant. Means our refrigerator to maintain this temperature constant. Okay, here it have written a domestic refrigerator maintains temperature minus 8 degrees Celsius constant. Okay, and this is atmospheric means what? Whatever the condenser is there, that where we can call condenser is there, net structure is there at the back side of the refrigerator, where the heat is rejected. So that temperature is source temperature, where heat is rejected. So if to maintain the same temperature, 7.5 kilojoule amount of heat that refrigerator have to remove, okay, to the atmosphere. And at the same time, here as this is low temperature, this is high temperature, we have to supply some work W. Okay, and to do this, to remove this Q2, this is what we can say it as Q1. This is going to be Q2 is equal to 7.5 kilojoule per minute. If you consider it as a in kilowatt divided by 60, it is equal to 7.5 divided by 60 is equal to, I think, it is W is equal to 0. No, not W. It is equal to 0.125 kilojoule per second, or kilojoule per second we call it as a kilowatt. So this kilowatt amount of heat that refrigerator have to remove, okay, and at the same time it requires some W, and this refrigerator is what? Carnot refrigerator. Then how we can calculate? Then we have to calculate the work required. So now I will solve here. So in our simple way, so COP of this Carnot, I will say C for Carnot refrigerator. What is formula for COP of Carnot refrigerator? If temperatures are knowing to us, anybody? Okay, anybody? If temperature
T1 divided by T1 minus T2.
T2 divided by T1 minus T2. Write down. So COP of current refrigerator in this case it will become what? T2 divided by T1 minus T2. We calculate COP in that case. COP of refrigerator. Calculate. What is T2 is coming as? We'll go in another method. Which is so T2 is how much T2 is there? 265. 265 divided by T1 minus T2 is how much it is coming? 300 minus 265 is how much? 35, correct? Na? Write down. And this way, our method you write down. Okay. Then 265 divided by 35, how much it is coming? Anybody? COP is coming as what? 265 divided by here 35. I think it is coming. Anybody?
7.57.
1.5. So COP of our refrigerator, Carnot refrigerator is maximum. It is coming as what? Say 1.5. Okay. Now this is a Carnot, but in general, any refrigerator COP you can find by formula. Anybody, what is formula? COP of, again, refrigerator is also given by in terms of heat ratios. What is that? Heat here absorbed means whatever liquid is there, that is have to be absorbed. Q2 divided by work supply. Directly you can say W, or Q2 divided by Q1 minus Q2. D is equal to how much? Say 1.5. Okay. And we want W, therefore W is equal to how much is there? Equal to Q2. Already Q2 where my this is going to be only Q2. Q2 divided by say 1.5. Okay, and Q2 is equal to how much Q2 is there? 7.5 is 0.125 kilowatt divided by 7.5, and is equal to what? 0.0165. 0.0165. The answer. Okay. So this is the such kind of numericals now they are asking. Now, last question to you means what all? I only change the values now. This is minus 10, you can take consider. Here you consider atmospheric as a 30 degrees Celsius. Draw schematic, and here you can consider 10 kilojoule per minute. 10 kilojoule per minute. 10 kilojoule minus 10 and 30. So this is the last numerical. Homework means this is our last problem, practice problem. See your preparator solve it, and now I request all to give your attendance. I request to give the attendance. At the same time, write your roll number and then solve our numerical. Kunal Shetty 65. Wait, what I am behind it. Answers. I request answers. Huh? Okay. Good. So our students are giving answers. Point not 25 kilowatt. So many students are solving. Good. This kind of involvement, if it there, then it is very easy for me also to teach the subject. So actually, it is not your problem. Last time we have faced a problem of internet, etc. So therefore, some disturbance happen. So we'll take hope that this kind of atmosphere, this kind of thing will continue. Okay, Shubham, Mayur, Samesh, okay, all are Ajit, okay, 0.025 kilowatt. So, okay, so today I think we have taken numerical. So next class, some level of difficulty level will increase, but I request everybody, today I will send this PPT to you also there. because now theory of this we have completed. So next class, I think we will discuss about the entropy. Only one article is remain now, entropy, and change of entropy during different thermodynamic processes. And in this big chapter, first chapter will complete next class. Definitely, I think 2 hours are there. So next 2 hours, I think within next 2 hours, we will complete the first, that is basic laws of thermodynamics. And I will send this PPT today only, so that we will go through the all the Kelvin Planck statement, Clausius statement. Okay, then what is equivalence, etc. If doubts are there, you can ask in that lecture, or everybody is having my phone number. You can WhatsApp me if your doubts are there on my number. I will welcome these doubts. So if possible, in WhatsApp, in real WhatsApp, if you're doing, it will be good, so that our everybody's class time. If a problem is general, a doubt is general, then that will cover in the next class. Otherwise, if you are having only you are having only doubt about that, then if WhatsApp interaction is good. So today, I think shall we stop, conclude? Anybody from here? Anybody is giving remark today? Shall we conclude?
Okay, sir, you can. Please.
Okay, sir.
Okay. Okay. So today we'll conclude. So now if you quit the lecture, there is no problem. Okay.
Okay,
Thank you.
thank you, sir.
Attend.
Take care.
Okay. Okay. Thank you. Same to you. हा काय एक मिनिट नंतर लेक्चर संपूर्ण माझं व्हिडिओ क्लोज कर एक मिनिट रेकॉर्ड माझी होईल थांबा ह्याच्यात जाऊ दे मला त्या व्हिडिओ क्लोज करू दे